Hey, good morning again, everybody. This is Hurricane Specialist Robbie Berg. I'm now standing in the NHC Tropical Analysis and Forecast branch, also known as TAFB. TAFB is one of the main three branches of the National Hurricane Center. They work shifts year-round, and they're producing both what we call surface analyses and forecasts for the marine areas that we have responsibility for. So to start off with, we're going to talk to forecaster Michael Tikacek, who is going to talk about the surface analysis function of TAFB and what you're doing when you're working shifts here in the unit.
Thank you. The two main duties of the analyst are A, surface map analysis. We do a pressure analysis every 3 hours. We use real observations from land stations, from boats, from buoys, any sources. We combine that with satellite imagery analysis. This map is used by everybody in the world. The public sees it on television, in print, and newspapers. The second big chore for us is the tropical weather discussion. Everybody in Caribbean island nations to the south of the USA border refers to the tropical weather discussion. That is a written summary of the map analysis, the satellite imagery, and any important weather, cold fronts, tropical cyclones, tropical waves. We follow the tropical waves during the whole calendar season.
Yeah, I was going to mention those tropical waves are important. You're analyzing the locations of those waves because once we get to the peak of the hurricane season, it's often those waves that go on to becoming actual full-fledged hurricanes.
That's
and
correct.
So we can't make a forecast for if a hurricane is going to form until we know where those waves are actually located.
That's correct. Everything starts with the basic, which is the surface observation and the surface map analysis. You're able to build the forecast once you know where features are and how the pressure pattern is in your forecast responsibility area.
You probably agree with me. I say when you're in school learning meteorology, surface analysis is probably one of the very first things that you learn before you actually go on to learning actual meteorology.
I was telling somebody yesterday, my first course in college was map and chart analysis.
Right. And so even to this day, it's 2018, we're still doing it. We're doing it on a computer. We're not really doing hand on paper anymore.
We used to do, yes. We used to do.
But we are doing it here on the computer. So thanks, Tiki. This is, again, one of the main functions here of the Tropical Analysis Forecast branch. Now what we're going to do is we're going to move on to talk to Jeff Lewitsky, who is actually the Atlantic forecaster on duty today. Jeff, why don't you tell us what you're doing here on the screen?
Sure. Well, just like Mike said, you can't have a good forecast without a good analysis. So I have satellite, buoy, ship observations up. I have radar over here. And then on this screen, I'm actually creating the forecast using a gridded database. And with this software, I can zoom in on our area of responsibility, which includes the Gulf of Mexico, the Caribbean Sea, and the tropical Atlantic. And we do the same thing in the tropical Pacific. And we forecast 10-meter wind speeds, 10-meter wind gusts, significant wave height in feet, and also some other wave information, swell height and swell direction, and wave period. And this gridded database, we populate this using model data, of course, with the analysis to start out with. And out of the gridded database, all of our text products automatically get created from the gridded database, which you can see an example of one here. In addition to the text products, our radio facts charts, which we've been producing for decades here, received by ships out at sea, are created from that same gridded database. So we ingest all the observations, all the computer model data, create the gridded database, and all of these products fall out of it in a consistent way.
Great. So, Jeff, what kind of ships and mariners are you serving out in the high seas of the Atlantic? And we're not talking about just day trippers going out and taking their boat out for the day.
Sure. Well, some of the observations I have in here are coming from cruise ships traveling from Miami into the Caribbean Sea and all other kinds of routes here. So a lot of cruise ships provide us with information, and in turn we give them the forecast. Also a lot of containers, shipping companies use our information, but there are also in the sailboat community our users coming from there as well. People going out to the Bahamas, and in the Pacific, people traveling along the coast of Central America, coming down from California, along Mexico, all the way to the Panama Canal. So we have a wide range of users here.
Right. So and obviously you guys are producing these forecasts year-round. It's not just during hurricane season.
Right.
But you also have hazards marine-wise that occur even outside the hurricane season.
Right, yeah, we're here 24/7, whether it's hurricane season or not. We're producing these marine forecasts, which are critical to everyone. In hurricane season, we ramp up even more, and we do some special product products, which Martin's going to talk about next, I think.
Yeah, great, Jeff. So thanks for doing that. And with that, we're going to actually go over to talk to Martin Nelson. He's actually on the Pacific desk today, working on the high seas, offshores out there. But one of the other functions that we actually do here at TAFB is what we call the Dvorak Classification. So when we're making hurricane forecasts, we have to know how strong hurricanes are from the get-go. And oftentimes we don't have aircraft to actually tell us how strong the storm is, so we rely on these satellite methods. And I'll let Martin talk about what he does in his role with the Dvorak technique.
Hi, Robbie. This is a quick infrared loop of convection along the Monsoon Trough in the East Pacific Ocean. And this would be what you would probably normally see on television here in what we call the color MB curve. But if we were to zoom in on this and change the curve to an enhancement curve we call the BD curve, which is mostly a grayscale curve, is what a meteorologist uses to actually measure banding associated with a developing tropical cyclone. We really don't have one active right now, but let's say this cluster here was a cyclone developing within the monsoon trough. We would look at these grayscales, and where we would find the low-level center, we would measure actually in degrees of a compass the amount of curvature there, and when it meets certain criteria, we would start to begin to show tropical depression development, and then later as the curve banding wraps about 50% around the center and persists for a good 12 to 15 hours or so, then we begin to start thinking about it becoming a tropical cyclone, i.e. tropical storm.
Right. And then once you actually have a hurricane with an eye, the classification technique allows you to take the temperature difference between the eye and the eye wall to come up with the intensity of the storm.
Correct. We get in and we stop it, and we really zoom in and we look at it close, and we have measurements we can take with distance, and we can also look at temperatures, and we look at that, and that's how we use to determine the strength of a developing hurricane.
Right. So without this function at TAFB, we'd almost be lost over the hurricane specialist unit, because we need that initial intensity estimate before we can actually make the forecast.
Correct, and this is most important when a system is well out over the ocean beyond the range of reconnaissance aircraft.
Right, yeah, we often have storms that form out near Africa, the Cape Verde Islands, and we can't send the planes that far out, so we have to rely on the Dvorak technique for that purpose. Okay, so thank you, Martin. Is there anything else you'd like to say?
No, this is, we have a lot of nice tools here. This is, we're looking at different types of moisture and so forth, this precipitable water, and we look at it and watch it in the tropical waves coming from Africa.
And you can see in this case, Martin, as I said earlier, is doing the Pacific marine forecast. So he's looking at all the areas off the coast of Mexico out to about 140 degrees west, and looking at all the weather features in that area, and then also the wave forecast as well.
Right.
So, okay. Thanks, Martin.
Thank you.
So that's the Tropical Analysis and Forecast branch. Again, one of the main 3 units from the National Hurricane Center. Thanks for joining us. We'll be back on live at 11 o'clock with the next stop of the Hurricane Center.